In this video, I'm working on a vehicle that has no blower motor operational. So across all speeds inside in the cabin, there's absolutely nothing happening. Now the vehicle I'm working on is a Honda, but you can apply the same principles for testing and diagnosing on your vehicle. So without further ado, let's get into it. Now there are a couple of different ways you can start your tests on these, and also a couple of different units you can use. You can use a test light, you can use a multimeter. In this video I'm going to be using my power probe, but any one of those units will easily diagnose the fault just the same. So you can go for the fuse, you could go for a relay. In most cases I go direct to the blower motor to see if I'm having an issue with power going down to it or a failed blower motor. So that's what I'm trying to decipher straight away. So in this case, in the passenger footwell is where the blower motor is located. Just one little plastic cover was in the way and I had direct access to it. Now when the ignition is on or the vehicle is running and the fan speeds are turned on, with the blower motor 2-wire setup, the white and blue wire is the power from the fuse side. The blue and black wire is the ground signal coming from the transistor, and what you should be seeing is a power on one side and a ground side switching on the other side. Now as you could see in this video here, we had power on both sides, so we had battery voltage showing up on both sides. Now with that quick and simple check, I can rule out the fuse and the relay, as there is power going down to the blower motor and it is a grounding issue. There's no ground side switching happening at the blower motor. So the next check I do, which is just to the right side of the blower motor, is check that blower motor transistor. That's held in by 2 screws and it's a 4-wire plug that is on the back of it. So this blower motor transistor having 4 wires, 2 of those wires on pin 1 and 3 are the control wires. So pin 1 has a transistor control from the heater control panel, and pin 3 is the blower feedback to the heater control panel. The pins I'm worrying about after I do those simple checks with my power probe is pin 2 and pin 4. Pin 2 is the body ground, so that's the black wire, and pin 4 is a blue and black wire which feeds to the blower motor. Now between those two, that's where the switching should be happening. So you're going to have a switching back and forward from pin 2 to pin 4. So I decide to do something very simple and straightforward. I just grab 2 wires and I make a fusible link to check if I can get the blower motor back up and running and see if the circuit can be completed. And as you could see there, by bypassing the transistor, using that fusible link, you don't have to use a fusible link, you can use whatever you want. I was able to get the fan back up and running again and confirm the fault is in the transistor. So I went ahead and ordered a new part, and the vehicle came back in as soon as that part arrived. So just a little bit of the layout of these systems. So you have ignition power on, it goes to the blower motor fuse, down to the blower motor relay, and then on to either a resistor or a variable speed transistor / control module. And the difference between a resistor and a transistor is you're going to have fixed speeds across a resistor. So on those vehicles you'll have a 1, 2, 3 and maybe even 4 and 5 speeds. And on a variable speed transistor you're going to have multitude of speeds across a climate control type setup. So you're going to have more control over it versus a resistor where it's just those stepped 1, 2, 3 and 4, for example, and then that feeds down to the blower motor. So now that I have the new part come into stock, it was a genuine Honda part, I go ahead and fit it. Very simple, 2 screws and disconnect the 4-wire plug. With the back in, I just showcase here some of the readings that you would expect to see with a working unit. Again, ignition on, fans running, or vehicle running with the fans turned on. And now with the system fully functional, we can see at the transistor between pin 2 and pin 4 we have a ground, and it's a ground side switching signal coming through it. Up at the blower motor itself, again the readings have changed, and we now have a power on one side and we have a switching ground on the other, so we can hear that audible beep as it changes. And if you're like me, you want to know why that blower motor transistor failed, so in this next clip I'm going to show you what actually failed on that unit. So I have the failed part here in front of me. I'm going to take this back cover off now. I'm going to show you the layout, and I'm going to show you the part that has failed, which caused this unit to need to be replaced. So we just pull that off. And what you're looking at here is, first of all, this is the capacitor here. You have 3 resistors, 1, 2, and 3. And on this side here, you have 3 solders as well. So 1, 2, 3. And that goes to the 3-pin MOSFET transistor, which is underneath on the lower side, covered in heatsink. And on this side here you have another solder and another solder, and on the underside of that is a thermal cutoff. So you have your MOSFET, you have your thermal cutoff, all on the underside covered in heatsink. The MOSFET is held in by a screw, Phillips head screw on the underside. And what I have found out that has since failed by doing some checks is between here and here is an open line. So the thermal cutoff has failed on this side, and that's why this unit needed to be replaced. And I'm just going to show you quickly with the multimeter the test across both sides showing an open line. And that's why that unit has failed. And that is it. That is the blower motor issue fixed. It's now working on all speeds, and I'm able to give this back to the customer. By following those simple steps, checking your powers, checking your grounds, checking to see if the blower motor is working. If you can direct feed it and you want to go that way, you can do it. Creating a fusible link in the resistor side was able to get the blower motor back up and running, and we're able to confirm the faulty part, order it in, then fit it, and now we can give it back to the customer. Really hope you enjoyed this video. I hope you found it useful and informative. If you did, please like, share, comment, and subscribe. And I hope to see you in the next one. Thanks for watching.